Hey folks, so I wanted to make this video on this pretty awesome serial communication library that I've built for C++, and I've built a reader for the Arduino, and basically you can kind of follow. I'm going to try and show you how this code works and everything, but the idea is that you have C++ code running on your computer, and you want to send data to the Arduino serially, and then the Arduino do some calculations and then send a number back. And so I have an Arduino Uno here. Hopefully you can see it in the bottom right half of your screen. There's a shield on this Arduino, but I'm not using it in this video. And I have it hooked up USB. If you look at the Arduino code over here, I have it hooked up to, I'm on a Linux computer, so I've got it hooked up to TTY ACM0. I've got two Arduinos hooked up in here, so it doesn't really matter. You just have to make sure that over here, when you're running the C++ code, you pick the right port. All of this code that I'm going to show you is open source, so there's two sides of the code. So there's the microcontroller Arduino Uno side, and this is serial communication. And in this video, I've got a lot of scripts here, like float array, hex test, int array 1, yada yada. The one I'm going to show you is send 6, receive 6. And there's a send and receive CPP file for Arduino. And then there's a send and receive INO file here, and that's the code that you're seeing here. You see there's some code in the background I'll talk about in a second. On the desktop side, there is, if you go to my C library, again open source, there is a serial.cpp and a serial.h. And then I've got some test scripts in here, and again I'm going to show you the send 6, receive 6. And there's a main.c file in here. And then there's a create links file over here. So basically, if you let me clear this. If you're in terminal, if you're using Linux and you access the send6 receive library, what you need to do is create these symbolic links to serial.cpp and serial.h that link to the other directory. So when you compile the code, it compiles the main.c file, the serial.cpp file, and then copies those into modules and then compiles the whole thing together. So at the end of the day, what you're left with is this /run.exe. So that's desktop side. Arduino side, all you need to do is just pick the right board, the right port, and then you can just click flash board there, and you're all set. So let's talk about this code on the C++ side. So basically what I do is I just printf and I say, hey, I'm initializing the /dev port, okay? And then I do this line of code here, which is my equals serial init. I give it the port number and the baud rate. And this baud rate is really important because over here on the Arduino side, you need to do serial.begin and make sure that the baud rate is the same for both on the Arduino side and the desktop side. So let's take a look at this serial.cpp code. So if you go to serial.h, I am collaborating on this software with somebody who's running Windows. And so there's this #if_def Windows here, and there's this #if_def Linux here. And basically what I do is, apparently in Windows for serial communication, you have to use this function, or it's a variable declaration called handle. And all I do is just everywhere there's a handle, I change it to an int, because on Linux, when you're opening a serial port, you just need an integer. And so what I do is I create this external variable called my, and that's why over here I don't need to declare it here because I actually declare it in the header file, and all I do is just #include that header file here in the main.cpp. Here are all my header files I include. I go ahead and include serial.h, and then this is where I create my handle. So then I have all of these serial functions. So I have the initialize the serial port, serial init, serial get, which gets a character. I have serial put, which puts a character. I have serial put string, which sends a string. And then I added all of these, which is serial put array, which is instead of sending a string, you actually send an array of numbers. And then I have an overloaded function so that you can echo the variables back. And then I have serial get array, which gets an array from the Arduino. And then I have serial get all, which is just a debug function to get everything that the Arduino is sending. And then I have these two debug functions here that I actually use every time just to make sure things are working. As I say hello to the Arduino in a specific way, and then the Arduino says hello back, and I get the hello. So those are my functions there in the header library. If we move to the serial, and hopefully you saw that. I realized that my screen is here, so hopefully here are those functions here that I declare in the serial header file. Now, let me make sure I scroll up. So in the serial init, where you give it the port name and the baud rate. If you just run init serial port, it creates these defaults here, and I don't like just blindly doing defaults, so I use this function here. So I give it the COM port name and the baud rate. If you're on Windows, this is what you're doing. My colleague copied and pasted this from a tutorial online somewhere, probably on Stack Overflow or something like that. I'm guessing because I did the same. I looked up how to do Linux communication, and I found this. And so basically, you open the port, read write, no CTTY, which it creates some termio structure and call it TTY for convention, and creates some memory objects, and then it sets all of these different flags. And unfortunately, I don't know what these flags do. I Googled it, and I threw it in there, and it sets up the port. All I'm going to show you is once you set up the port, how do you actually send variables to the computer, or to the Arduino, sorry. So once you initialize a serial port, you have this function, you have this variable my. And in order to say hello to the Arduino, what I do is I send, and okay, actually, so this is older code. So I think I have, where's serial put hello? There's serial put hello, yeah. So let's, and then is there sending? Yeah, all of that is in there. So let's do, let's delete this and say serial, and I'll push this code, serial put hello, and then what do I have to give it? I have to give it the handle, my, and then I want it to echo to the screen. And then I want to get hello, so I'm going to do the exact same thing. I'm going to delete this, and I'm going to say serial get hello, my 1. Okay, and let's make sure this compiles. Oops. Let's see. Oh, okay, that's right. I have to send it the address to my, because you're sending a pointer. Okay, and then let's try make again. Okay, great. So what does serial put hello do? So serial put hello says it's going to print to the computer sending w/r. And then it's going to send the character w, and it's going to send the character /r. Now, if you look over here on the Arduino, there is a do while loop that is looping until it reads a w. Once it reads a w, the LED is going to turn on, and then it's going to go into a while loop where it's reading a /r. So basically, the computer, my laptop, is sending w/r so that it breaks out of these two infinite while loops. Once the Arduino breaks out of those two infinite while loops, it's going to send w/r/n. I didn't make this convention. My colleague is in his 60s, and he dates back to when computers were sending line feeds and carriage returns and things like that. And so this is his way of saying, hey Arduino, are you listening? And then this is a way of saying, yes computer, I am listening. And so once the Arduino receives that w/r, it's going to serial print w/r/n. And if you notice, the ASCII code for those, I looked these up ahead of time. The ASCII code for W is 119. The ASCII code for /r is 13. And the ASCII code for /n is 10. And so in the main.c file, after I put hello, I'm going to get hello. And the function for get hello jumps into this for loop where it loops 3 times, and it gets the character and prints it to the home screen. Now I have this return 0 to basically break the code, because if we run this, so if I run /run.exe, it's going to sleep for 5 seconds to allow the Arduino to reboot, and then it's going to send the w/r, it sent it, and then it's reading the w/r/n, and there you go, it read the 119, the 13, and the 10. Just to prove to you that this is working, I'm going to send the letter A, and I'm going to flash the Arduino. And I'm going to, I don't need to change the computer side. I'm going to run the code again. The Arduino is going to sleep for 5 seconds. And now it's going to send 119, 13, and 97. And if you look up the if you look up the ASCII code for the letter A, it is 97. And so that just sort of proves to you that it's actually doing what we're doing. Okay, so this is all well and good. I said hello to the Arduino, and the Arduino responded. But I want to send numbers, okay? So I have these floats. I have these random numbers. I have 6 of them, and I put it into this number array. So I put number 1 into 0, number 2 into 1. I put all of these things into the number array. And then I create this function called serial put array. Now what does this function do? So let's run into here and let's go into serial put array. So that is here. So what serial put array does is it uses this inversion tool. So if you go here, it creates this union in parser, and it creates the float version of the variable and the long version of the variable. So a float is a floating point number. A long is a 32-bit integer, which is any number between like minus 32,000 to 32,000 or something like that. The reason why we make it an integer is because, let's go to serial CPP, let's look for serial put array. Here's serial put array. We save the number as the float version, and then we convert it to an integer using this inversion tool, and then we do an sprintf, and we convert the integer to hex. That's what this X stands for, with 8 digits. So we say send an 8-digit hex number, so convert this integer to hex, and then it's going to print that string to the Arduino. And so the Arduino is expecting H colon and then 8 hex digits. And then after every number, it sends a /r. No, sorry. After it sends 3 numbers, the computer sends /r. So if we look over here on the Arduino, I commented out this send receive number. And if I go over here to send receive, this is what the code is doing. It is in this infinite while loop where it reads the character, as long as it's not -1. -1 means that it didn't get a character. It reads the character, and then once it reads /r, it null terminates the string and then moves to the next one. So remember, this serial put array is sending 6 numbers. So the first 3, it's going to send H colon 8 digits, H colon 8 digits, H colon 8 digits of hex, and then /r. And all of that is going to go into first line. And so that's what I have here. So this is the first string that it's going to send. Then it's going to send another 3 numbers. And it's going to be H colon 8 digits, H colon 8 digits, H colon 8 digits, and then followed by a /r. Once that's done, it's going to take each one of these strings and extract, if you look, 2 through 10 are the first 8 digits, 13 through 21 are the second 8 digits, and it's going to use this tool where it reads in 4 bytes at a time and converts each digit to a number. And so that means it's going to convert it to another integer. Once it converts it to an integer, it uses this in parser again to convert it from the integer to the float. And that's what this magx is here. Okay? It does that for magx, magy, magz, which is the first 3 numbers. And then it does it for the second 3 numbers, gyro x, gyro y, gyro z. And then at the end of the day, it adds those 2 numbers together, converts the numbers back to, these are the float versions, it converts it back to an integer, and then sends it as a long hex. It has to be a long hex. So on the desktop, on the laptop, a integer is 32 bits. On the Arduino, an integer, I think, is 16 bits. And so in order to get 32 bits, you have to make it a long hex. And so it converts this integer to a long hex, again with 8 digits, and sends it back to the computer. So then on the desktop side, when I serial put array, all I need to do is serial get array, and then all I need to do is go down to that function, serial get array, which is here. That's an overloaded function there. And all it does, let me make sure I have echoes turned on. I think the default is echo turned on. Yeah, okay, cool. It's going to serial get array, and what that's going to do is it's going to do the exact same thing the Arduino did. It's going to read the first line until it gets to a /r. Then it's going to read, it's only reading 3 numbers, so it doesn't need to worry about that. And then it's going to, read the first integer 2 to 10. It's going to bit shift 4 times, and then it is going to do this computation where it subtracts off the ASCII code A, adds 10, all of this thing, and then finally converts the integer to a float and then saves it in the number array. So then when we're done, all we do is just print the received number array and the code is done. I went through that fairly quickly. I would encourage you to go to my GitHub and look at the C test scripts send 6, receive 6, and look at main.c. This is the desktop side. And even look at the C library and look at the serial.cpp and try to make heads or tails of it. And then at the same time, go to the microcontroller side and look at the send 6 in the microcontrollers, Arduino, Uno, serial, send 6, receive 6, and look at the send receive CPP and see if you can make sense of this. At the end of the day, if I get rid of this return 0, okay, and then go over to here and compile this, and then go to the Arduino and make sure that this is uncommented and run that and flash that. Over here, I can type in /run. It's going to wait for the Arduino to reboot, boot 5 seconds, and then it's going to spit out a whole lot of stuff. So let's unpack what's happening. Okay, so it sent the hello, the W/R. It received the hello from the Arduino. And then the computer, my laptop, said, all right, I'm going to send negative 3.6, which is negative, that's a really big number, that's a really big integer. Again, it's a 32-bit integer. And then it converts it to hex. So here's this number in hex, and it sends those 8 digits to the Arduino. The Arduino, again, is going to then get, the laptop then takes 4.5 and converts it to an integer, and then to hex, and 2.4. And it does this for all of these numbers, and it sends all of the numbers. The Arduino is, we can't see the output from the Arduino, but the Arduino is reading all of these characters, converting them to integers, then converting them to floats, and then adding the 2 floats together and sending it back. So then the laptop is just waiting for the response. So that's where it says here, waiting for characters. Well, then it receives H:40 blah, 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 blah. These are all the characters it receives. And then it receives a /r. Okay? And then it converts that number to a float. Well, first it converts it to an integer, and then it converts it to a float at the bottom. So then it receives another integer, and another integer. It receives 3 integers, and at the end of the day, it receives 6.2, 1.7, and 2.7. And if you look, 6.2 is negative 3.6 plus 9.8. If you add those two together, you get 6.2. And if you do 4.5 plus negative 2.8, that is 1.7. And so it is indeed adding the two numbers together. And at that point, we're getting serial back and forth. So again, make sure to try to look at my GitHub and try to make heads or tails of this. Post in the comments if you have any questions. And I hope you have a good day, and I hope you enjoyed this video.